Okay, so hello, Marina Alberti. I'm so happy to be talking with you on a podcast that I am labeling Evolving Complex Systems in Seattle and Beyond. So, first of all, welcome.
Thank you. Thanks for having me.
And you are a unique person in your background because you're both trained in urban development and ecology, evolution, and complex systems. Not many people combine those two bodies of knowledge. And I wonder if you could just begin on a personal level to explain how it is that you acquired both of these bodies of knowledge. And then for a long time at the University of Washington in Seattle have been applying this, including your book, Cities That Think Like Planets, which we will be talking about. And I believe you're working on a new book as well, which you're welcome to describe. But first, your personal story as to how you acquired this unique perspective on urban planning.
Yes, thank you. Thanks for asking this question. Actually, cities have captured my imagination since I was a child. Um, I remember standing under the Rome's aqueducts
Hmm.
and learning how Romans built them more than 2,000 years ago, using just gravity and the natural slopes to move water for long distances to the city. And I saw humans at that time reshaping landscapes to secure water, much like ants build very complex networks to reach food. So at that time, I didn't have the language um, to capture what I was seeing, but I actually realize now, rethinking that experience, that it was the first glimpse I had of humans as ecosystem engineers. So yeah, I trained in architecture and urban planning in Venice, which is also another place where
Yeah,
the built forms and the
yeah,
environment are quite co-evolved for a long time.
yeah.
But to actually understand cities as how they really work, I really realized that I needed to move beyond design and planning and really learn the science of urban systems. So at MIT, where I did my PhD, I studied urban systems and infrastructure management. And then during my postdoc at Stanford, I was able to engage more directly and more deeply with ecology and also with complex system theory. So it is really that combination that taught me that cities are not like, first of all, only a human product, but they are and they are not just a static artifact, but seeing cities as a living system where interconnected networks of humans, technology shape the energy flows, the resources flows, also shape interactions among species, humans, and ultimately shape our behavior. So it's really the combination of disciplines that are my background. And I'm not sure that there is one component that is more important than the other. They all contributed to the vision that I have. Then the link to evolution came a little later. Over the past decade, we have starting to learn quite a bit about rapid evolution.
Hmm.
And it
And
became,
rapid evolution in non-human species, basically.
yeah, but rapid evolution of organisms that actually are changing on a pace that was not what in originally evolutionary biologists thought. So it became clear to me that cities are not just the ecological systems, but actually they are, we say, evolutionary forces. Because urban environment really impose strong and also new selective pressures, and many species respond rapidly to those changes. And we're starting to have quite a bit of evidence, also because evolutionary biologists become interested in actually studying cities finally.
Hmm.
uh, which is the realization that pushed me towards learning and studying ecoevolutionary dynamic. And ultimately, because those changes in the species that we are um, driving will have feedback in the ecosystem functions that we rely upon on a temporary scale. So ultimately, I was interested in studying not only evolutionary dynamic driven by urban systems, but how urban design can engage with the biological processes rather than override them. So how we can actually incorporate evolutionary process and biological processes as a part of the urban fabric. So as it became clear, my expertise emerged from really integrating together planning, ecology, complex systems, and also, as I say, the growing recognitions that I speak first in this earlier book, Cities That Think Like a Planet, that cities actively are reshaping or shaping evolution on a planetary scale.
Let me amplify a couple of things, Marina. But first, tell me, it's quite extraordinary that you should go from a PhD in urban planning at MIT to Stanford. I think you said you worked with Paul Ehrlich, is that right? Could you say
Yes.
just a little bit more about how you took that extraordinary step? Most people
Uh,
wouldn't even understand how, how that would happen. I'd love to know a little bit more about that.
yeah, me too. I it's very interesting. I'm a very curious person. I really keep want to learn more. I don't think I know enough, although my long academic experience, I do realize that in order to engage with ecological processes and evolutionary processes, I need to understand more deeply ecology and evolution. And I realized that because of my background, I had quite a bit of a background in biology already, but not at the level of understanding how it could be integrated in urban systems. I have to admit that it was really a challenge to speak to biologists 30, 30 years ago, more. I'm talking about 30 years ago. It was a long time ago. Now, urban ecology is a field that is a legitimate field. Urban planners and ecologists speak to each other. At that time, at Stanford, for example, where the urban study is a very limited uh, uh, program, actually, nobody in the biology department knew what an urban planner does.
Yeah, that doesn't surprise me.
They in biology, people were more had greater experience with
Hmm.
economics, but not with urban planning. And it was a challenge because with the language, we didn't have enough language to speak it at a productive level. And so it was not simple. It was challenging for me to integrate my knowledge and explain my concept and understand also their perspective. So, but it taught me quite a bit. In fact, the first things I did when I came to University of Washington as a professor in urban planning, I did um, start a program with John Marsleff and other people in John Marsleff is a well-known wildlife biologist studying
That's right.
crows. And together we uh, got a grant from the National Science Foundation. It was the first IGERT grant, an
Hmm.
interdisciplinary program to train a PhD student through a very interdisciplinary program. It was a training interdisciplinary PhD. And we went through this program in 2000 for 5 years. And I realized that all my experience of being as a planner in a biology department was critical for understanding what were our obstacles and how to start to talk to each other. Where we are now is a completely different world from in terms of the possibilities of building interdisciplinary research. Um, and that's what I keep telling my students, that they're lucky because now they can actually move way beyond where we have been. So, uh, why I went there, it was simply that I was very curious and I wanted, and I took the risk. It was a clear risk to do that for my academic career. Um, and but it did teach me a lot. It was a very important experience of where I am now.
Well, let me fill in some background here because, of course, as you know, I'm trained as a biologist, and so I think when we look at this coming together that's taken place over the decades, you said 30 years, but I'll say 50 years because at least that's how long I've been around. But um, one point to make is that the biological study of ecosystems and the biological study of species were really two subfields of ecology. And it took a while and still a work in progress for those to become integrated with each other. The system level approach tending to compartmentalize nature into such things as trophic levels and so on and so forth, not really keeping track of the species. Whereas the species level is studying each species as a product of selection, genetic evolution with its own agenda, basically strategies for survival and reproduction. And then somehow all of those combine in order to form whole ecosystems. So those are two subfields still growing together. Then, as you say, almost everyone regarded evolution as a slow process, so that that did not take place over ecological timescales. And it was only in the last, I don't know, 30 years or so would probably be about right, that people began to realize that genetic evolution can operate on ecological timescales. Even a single generation can be sufficient for meaningful genetic change to take place. And then another development was to regard human cultural evolution as a Darwinian process, because up until then, the study of cultural evolution was separated from the study of biological evolution and often in perceived opposition to it, so that the sociologists and the cultural anthropologists would criticize the biologists for being biological determinists. And so they themselves would study culture in a way which, in their own minds, had little to do with Darwinian evolution. And so, but over the last few decades now, cultural evolution is increasingly being studied as a Darwinian process, and of course, a very fast-paced one. And so, what that means is, in the context of cities, when you talk about cities acting as selection forces and basically shaping evolution, that goes for the genetic evolution of non-human species. It goes to some extent for the genetic evolution of humans. That's fascinating to think about. But also, and more in a more mundane sense, it goes for the cultural evolution of of humans and non-humans because they have cultural traditions too. So all of this is like what's been coming together. And like you, I think anyone who's working in this space should count themselves lucky that that so much is going on and that so much is coming together. So, do you have any comment on that? Just that's my own observations on what you've been saying.
Yeah, I think you're completely right. There is still and actually, I believe that the still cultural evolution and biological evolution are two worlds. I do, in fact, I do think that the revolution that has occurred in urban ecology still has to occur in evolutionary biology. I work with evolutionary biologists, and it seems to me that I'm starting again from scratch to communicate with a different world because I realized that evolutionary biologists and ecologists are have not talked to each other very much. and still are in two different time scale and time frames. But I think things are changing more rapidly, and there is
Yeah.
much more interest on, and so the issue of biological, I haven't um, dealt directly with the human evolution, but I do, um, I'm particularly interested in co-evolution between human and non other organisms. In fact, my more recent work that we'll talk maybe later about multi-species, multi-species, the emergence of multi-species design has to do with the understanding that organisms are agents, other organisms, not just humans, in a city. So the cities are not only human product, but actually cities are co-production of human and other organisms. They have agency. They have specific dynamics. And unless we understand that, and we understand the cities as a multi-species ecosystems, uh, that co-evolve, we will not be able to actually make, and the transformation is required to build resilient cities.
Yeah, and that's, I think that's very distinctive about what you do, Marina. There's very, very few people who have that approach. I think even the ones that take an evolutionary approach to cities don't include other species. They're entirely human-centric. And so for you to focus on multi-species, I think is, and we will spend a segment on that. Why don't you just describe what you had in mind for your book, and also your new book, if you like. But what were you trying to convey to the reader in your
Uh,
book? And begin with the title. What do you mean by cities that
Cities
think
that
like
think like
planets?
planets, you mean the
Yeah.
cities that think like, yeah. Well, cities that think like planet, um, in some way, is a call to action. Is to planners, or but also to the general public, to think that cities need to be we need to rethink cities at a global scale as a agent, as I said, of planetary evolution. So I argue that urbanization is actually a force of planetary evolution, because cities reshape habitat, alter selection pressures, reorganize energy and information flow, and doing so, they actually alter. It has the potential to also alter trajectories, both ecological and social trajectories, in a way that is global. So the book asks this question: how can we design cities that can learn, adapt, coexist with those biophysical processes that we are interacting with? I say the book is a call to actions because it really urges us to rethink and design cities at the scale of a planet. Now, you probably you know that Aldo Leopold urged us to think like a mountain. Um, and what it meant is to, you know, think, and that was like more than a half century ago, to look beyond the human frame when we make a decision and attend to the dynamic of, um, attend to dynamic ecosystems. But at the time, the context was the region. What I think is that within the planetary change context, we need to rethink the city and the design of the city, building cities at a temporal and spatial scale. That is the scale at which planet work. Um, and but also I wanted to say a little more about the book, because probably one of the fundamental things that um, has shaped my understanding of cities from a planetary standpoint is that is the broader perspective of recognizing that cities are complex adaptive systems. And that what that means is they are open systems, they are non-linear, they constantly produce novelty, the disturbances are frequent, they change, um, and also the change depend on history. There in a city there are multiple interactions that take place, and so what I'm saying is that the current planning frame, which is based on a kind of steady state assumptions, doesn't hold anymore. So, and why? For urban systems do not return to stable equilibrium after a shock. They can shift in a completely different regime. Like
Yeah,
think about a coastal city that has long relied on kind of hard, a kind of defense wall or levee, pumps, and think about what has we are experiencing now. The transformation that due to rising seas and storm surges have pretty much broken the possibility of maintaining those systems under uh, resilience. So at some point, the a planning perspective as an incremental change doesn't work anymore. So what I emphasize in my work is that to really reframe resilience as a um, dynamic process, as a dynamic evolving process, and the city need to reorganize around a totally different logic. So rather than resisting a change or resisting water, to restructure completely land use, infrastructure, governance,
right,
to live with those changes. So
right.
that implies that we understand the actual nature of complex systems that shape cities. And one of the things that I also bring up all the time in my teaching is there are some very specific qualities of complex systems that can inform planning and that can change strategically where we're going. First, for example, is embracing uncertainty. When you think about a couple of human natural systems, and a city is a couple of human natural systems, the future of that systems cannot be predicted because the interactions among climate, technology, behaviors can generate outcomes that even the most sophisticated predictive models cannot anticipate. And
Yeah.
not because
So,
the models are not good enough, but because the predictive models rest on the assumptions that are built from historical variability. And we know now that they cannot fully actually capture the dynamics that are emerging from climate change is an example, right? So the variability that we're experiencing now was not in the past, right? Another important quality of to keep in mind is that cities are very heterogeneous, and they are shaped by the simultaneous decisions of multiple agents. And those agents, can think about households, businesses, governmental agency, also NGOs. They make choices that are interdependent. And those choices produce, again, very complex outcome. So planning must reflect that diversity of agents and those complexity. And then there is one other element that is really critical, especially when we think about evolution, which is feedback. Um, in a complex systems, and were shaped by human, ecological, and technological systems, feedback is a critical um, factors which can amplify or even dampen change. For example, you can imagine like carbon emissions, urban form, like exposure to risk are all processes that generate feedback into ecological health, human health, economic health, and all the functions that we rely upon. So for me, in the book, integrating concepts from ecology and evolution and complexity theory helped me to really rethink how planning really need to restructure around understanding the causal feedback uh, and interactions that shapes how really cities work. If we wanted to build policies that work, we need to inform those policies what with the actual causal mechanisms that generate those changes. So I'm thinking like frameworks where planning is able to anticipate nonlinear change, can kind of detect what are the potential emerging feedback that build strategy that are adaptive, that are leave open option opens, what is called in economic terms like optionality. So you can still have decisions that are made today, but optionality allows you, rather than to have rigid control on everything, to leave options for potential changes that we cannot anticipate today.
Yeah.
Many of the decisions that we made in the past, and now we are like infrastructure, that now we are blowing up because they're not anymore useful, was because they were built without thinking about unpredictable futures and unpredictable conditions. So cities that think like planet really is a call for urbanism and incorporate those concepts and treat cities as a living, co-evolving systems.
Well, I want to make, Marina, a distinction that I make between two meanings of complex adaptive systems, that key phrase, complex adaptive systems. One, meaning number one is a complex system that is adaptive as a whole system, as a single healthy organism, for example. Meaning number two is a complex system composed of agents following their own adaptive strategies. And the key insight is that the second meaning of complex system does not automatically self-organize into the first meaning. I mean, so many complex systems are of the second variety. They're composed of agents that are following their respective adaptive strategies, but that does not add up to a complex system that's adaptive as a whole system. It's like the distinction between what we call a smart city and a dumb city, and most cities are dumb that way. And of course, the whole challenge is to turn our cities into the first kind, something which is adaptive as a whole system. How do we do that? And later on in our conversation, I think we're going to get to strategic planning as a method for for doing that. But a method is required. It's like the opposite of laissez-faire. In economics, they have this stupid belief that the lower level pursuit of self-interest magically adds up to benefit the common good. Nobody believes that in urban planning. Can you imagine the idea that everyone making their independent driving decisions would result in a traffic system that works well? I mean, please. So so there's some sense in which system level design is required here. And it must take the form that you're calling attention to, because what we're designing is a complex system. There's radical uncertainty. You've already said that. There's multiple basins of attraction. Things can flip into what you called a new regime, basically. All these complexities, that's the kind of the raw material that we have to work with when we try to shape the system as something which works well for everyone within the system. And it ain't going to happen by itself. That's for sure. So anyhow, that's my view. I don't know. I think that that's also your view, but do you want to comment on that before we move on to the
Yeah,
next?
I can actually comment for bringing up the question, the reason why I moved towards this concept of multi-species cooperation. My new book that is coming out in 2026 is in press right now. Is I'm receiving the proofs very soon. It's called
Congratulations.
is Cities for a Shared Planet. It's coming and the full title is The Emergence of Multispecies Cooperation. And the word cooperation is critical there. The book is published by MIT Press.
Okay, good.
Now, in Cities That Think Like Planet, I show how evolutionary dynamics unfold in cities. I mean, in my new book, I actually explore a more radical idea: cities as a co-evolving multi-species ecosystems where humans cooperate with other organisms, with birds, insects, plants, fungi, um, even bacteria, to the idea to expand their shared capacity to survive in a rapidly changing world. So the idea is really a concept of symbiosis as an evolutionary outcome. Um, and I do believe, so although this is a very radical idea, I do think that humans can facilitate that process. So a multi-species perspective, for example, reframed the concept of resilience. So it shifts us away from designing simply with nature to serve human needs, towards kind of building habitats that sustain multiple forms of life. Because the idea is that in order for resilience to actually operate in a changing world, in that dynamic perspective that I presented before, means to recognize the resilience change and recognize the species that provide and those functions that maintain ecosystem stability over time have their own needs. So species have agency. Species that generate the ecological functions we rely upon require to be acknowledged as a part of the urban ecosystems. So it means moving through from treating the city as a kind of human artifact to understand that the city is actually a co-productive um, system. It's the idea of thinking rather than the city as an object, as the city as a web of relationships that is shaped by feedback among people, organisms, infrastructure, climate, and other biophysical processes that we interact with. And that what
Can you
that
make that can you make that a little more concrete? Can you give an example of that's a little more concrete? I don't know if it would uh,
yeah well I could um, I wanted to mention so it's a complex to explain because I rely on understanding the species cooperation in nature. And I assume that humans, if we break the assumptions that humans are separate from nature, but they are actually part of nature, we realize that actually humans can be in cooperating with other organisms the same way in which other organisms cooperate among themselves. And so the concept is there, the evidence of human cooperate with wildlife is limited. And perhaps we don't have very much documented experience, although there are examples. But I do imagine this as as a as some an evolutionary outcome rather than a given outcome. What I imagine is that we can, as humans, acknowledge that and we can facilitate a symbiotic relationship with other organisms. And I provide a concrete example because that reminds, again, as the starting point is to recognize the interdependence of human and natural system, not only from an environmental standpoint, but actually how all our functions from housing, transportation, uh, biodiversity, health, and climate adaptations are all connected. In Singapore, Cities in Nature vision is a compelling example of that. I had the opportunity to collaborate with the Singapore Urban Redevelopment Authority because has been part of um, the panel of expert of um, the Day Institute is an international panel of expert where they ask support for their long-term strategy and master plan. And their planning strategy integrate climate resilience, biodiversity conservation, social equity, housing affordability into a single strategy. So they tackle what are the current convergent crises that we are facing through an ecological lens rather than as a three separate policy arena. So the all the ecological infrastructure is not functioning only to maintain a certain, you know, ecological process, but is actually part of the urban fabric.
Hmm.
And when I say part of the urban fabric, I mean also supporting all the functions that um, that serve humans in cities. Now, expanding, I'm not arguing that any of that concept that I present in the book with a vision of 50 years from now is actually um, currently present in any of the reality, but I do see that the seeds of starting to recognize nature as part humans as a part of nature, and in fact, the concept of Singapore moving from the concept of the city in the garden to a city in nature is a really a shift, a conceptual shift
Yeah.
in thinking about natural processes. So
And we
bringing
have,
human into planning is not about kind of adding nature to to cities, but it's about acknowledging that the resilience of those cities depend on those evolutionary ecosystem functions that we rely upon.
and doesn't that require expanding the focus to bioregions, not cities, because cities, of course, are going to require a whole agricultural base, for example, and so on. So there's the nature that exists within the geographical boundaries of the city. But in terms of from an ecosystemic uh, standpoint, we would have to know about everything that's taking place outside the boundaries of the city, and ultimately planetary, because there's global supply chains and things like that. So I think that becomes, well, there's concentric circles that just go out until it envelops the whole planet. So speak on that theme. Shouldn't we be talking about bioregions, not cities? Shouldn't that be our key term? Or so what are your so it's Cascadia at not just Seattle or King County. What are your thoughts on that?
I do believe the bioregions for really the concept of bioregion force us to think about um, cities in context. So, like connected watershed, climate system, species pools, energy flows. But I do still think that cities remain crucial in many ways because they are where decisions, governments, and design intervention are made at the local scale. So, where community can be involved and engaged more directly. So it's neither, it's not either or. I think cities are nodes, and I see bioregions as networks. Like,
Okay.
and so I do believe that real solution need to be really be thinking across scale
Yeah.
because also there are interaction and trade-offs across those scales that in fact even natural ecosystems operate at that way and organisms operate at that way, and sometimes, for example, maintaining resilience mean to think about redundance across scale so that you can have substitution of depending on the circumstances and um, so I do believe that ecoregion bioregion are critical, but I do believe that there is a multi-scale perspective that need to be taken into account.
Yeah, that's great. That's great. Well, I want to proceed to the challenge if we are actually going to evolve complex systems in my first sense of the word, so that they're actually adaptive as whole systems then that requires a process. It's not going to just self-organize. That process is often called strategic planning. And that's something that you're experienced in. And so I'd like to have you talk about strategic planning, how it works, how it needs to work. And then I'll probably chip in with my own thoughts. But so let's focus on basically attempts to consciously improve the system and what form that must take. And so please weigh in on that subject.
Yeah, this is a very exciting project subject because one of the things that I teach in my department is strategic and scenario planning. But the starting point is that complex systems don't evolve through kind of top-down blueprint. And planning for a long time has been that.
Yeah.
They evolve through adaptive cycles, experimentation, learning, iterations, and that practical translation is a really, you know, participatory strategic planning. So first of all, co-producing knowledge with communities, building optionalities into our strategies. I was mentioning the Singapore experience of building optionality into infrastructure to create opportunities for making decisions in the future.
Could
And
you
also
elaborate on that? Did you say building optionality? Is that the term you used? Optionality?
optionality means that you leave completely open space. For example, in land use planning, you can identify areas where rather than allocating a specific land use, you leave that open to the future.
Okay.
And that
Okay.
decision. So optionality is about incorporating in decisions um, space, decision space that is left to
Okay.
future
So it's basically
possibilities.
built-in flexibility.
Yeah, so creating governance systems that can respond to surprise. So the
Yeah.
concept of surprise is critical, but one wanted to be practical here, and one way to work with this complexity is not to create um, a very complicated systems, but actually is to recognize those characteristics of complex systems. And scenario planning is a tool that is systematically uh, help to make decisions that are informed by those uncertainty. What that means, a scenario do not predict the future. They stretch our thinking on how the future can evolve so we can make better decisions under deep uncertainty. And deep uncertainty cannot be incorporated in any uh, model, predictive model. So they force us to explore interactions that are among uncertain trajectory, like such as climate change, population, technology, and governance are all trajectory they we know have a degree of uncertainty. So how can we start to explore what are the potential interactions among the endpoints of those uncertain conditions that may evolve? So scenario help planners identify, for example, where the vulnerability are, where are the sensitivities, where are early warning signals. And instead of aiming at optimality, where optimality assumes that you know the future, right? So you build the optimal solution for that future. They help test the robustness of the strategies under uncertain but plausible futures they may occur. And those can be quite divergent futures. One way I say that is to expand the boundary conditions of our model predictions, because models rely, as I said before, on past observations, and which are important, but their variability is limited. Where scenario explore interactions at the among those uncertain, so they shift really our attention from controlling the uncertainty to embrace uncertainty. incorporate in our decision making the potential outcomes that we cannot predict. Now, that doesn't mean that you don't incorporate still predictive modeling. In fact, paired with predictive modeling, they can reveal real informations and actually making invisible um, threshold
Yeah,
visible.
I think that there's a useful comparison with weather forecasting. So weather is a very complex system, so complex that it's impossible to predict the weather far into the future. Nevertheless, it's really important to predict the weather in the near future whenever possible. For that, we've developed many sophisticated models that we're always testing against each other and improving and evolving the models. And so um, human systems are like that. So also, and so I think they're just as complex as the weather, I think is one thing we're saying. That doesn't mean we can't model them or don't want to model them, but the models we have should be like weather forecasting models. There should be, and we should be testing them against the real outcomes again and again and again. And so is there a sense in which like social forecasting is like weather forecasting? Is that a useful comparison to make?
I think we can increase, I agree with you that we can increase the sophistication of our models, but now you're dealing with um, a meta complexity. In other words, you're dealing with two systems that are complex and they interact, and their interaction occur at their uncertain within their uncertainty. So what I'm saying is that weather forecasting, and they have their, you know, they have their confidence intervals, and often most models have their confidence interval that give you what are the, you know, uh, the degree of uncertainty around a certain trajectory. Where what I'm talking about is when you have two degree of uncertainty interacting with each other, and you only look at the interaction that occur um, in the, you know, most probabilist in the most probable outcome. That's what most models do when they look at interactions among two systems that are complex and uncertain. What that scenario allow you to do is to expand that condition, the assumption that the interaction occur only among among system at the um, probable trajectories, but they may actually interact at the and at the end point, at the tail, and that means that the outcome can be a surprise. This is why scenario. This is why scenario and model together can be useful, because
Yeah.
scenarios expand the boundary conditions, and then you can use those assumption, um, those unpredictable assumptions to then test the models.
Yeah.
So when I'm, scenario planning has been, scenario planning is being developed, in fact, and used by during by DH, the Dutch Dutch Shell in the 60s or 70s when there was the energy crisis.
Yeah. I mean,
Only
it's in the military. I mean, there's a large
exactly,
literature on.
and because of the those unpredictable futures are not modelable. I mean, I agree with you that we can make much more sophisticated, especially now with the availability of data, we can make much more sophisticated models that we have done in the past,
Yeah.
uh, real-time predictions, etc. But I do still believe that there are type of interaction that we cannot predict simply because we haven't even um, are beyond our understanding how those interactions may take place.
Well, and that's one reason why we have to be experimental, humble and
Yeah,
experimental, basically. So we have our best guess is going to be very provisional. We have to do something because another point about strategic planning is that we're not just trying to predict what's taking place. We're trying to change things for some desirable end state. So we you know we have some future that we're trying to head towards, um, some desirable future, and then the best of our knowledge is provisional. And so therefore, but we have to do something. That's the whole point. And then we have to assess it, and then we have to take stock, and we have to do it again and again and again. And what would that be but a Darwinian process? Selection, target of selection, variation, replication, again and again and again. So I think that's what we mean. That's what I mean by conscious cultural evolution. It's a conscious process of variation, selection, and replication spinning at many scales simultaneously. And that's what has to be orchestrated. That's how I see it. Is that also how you see it?
yeah. And I think that although we're speaking at a higher level and in some way abstract level, as you were pointing it before, there is actually a specific practical translation of those concepts in how we can institutionalize and create, um, yeah, create an infrastructure that, and I'm thinking about governmental infrastructure, uh, collaborative infrastructure between academia and also agencies and communities where those concepts can be actually practiced to achieve and facilitate this, what you call this cultural evolution. Because,
Yeah,
th-
yeah. And I think that, I mean, you mentioned Singapore. Singapore is a great example. It's also an example of a very uh, socialistic system, right? So, I mean, they're capable of collective action. In this case, that's it's going in a very benign direction. They basically they have goals that we would agree with, and they're bringing them about in a very holistic fashion. And then there's the question: is does a more laissez-faire society, more of a liberal democracy, is it capable of that kind of collective action? And if it's not, that's to its discredit. I mean, if a liberal democracy is incapable of cooperating at scale for this, then it's not worth wanting, you might say. So I hope that it can be. But what's your experience, Marina? You've been in Seattle for a long time and you've been consulted other cities. You've served as a consultant. And so, what's your experience? And let's focus on Seattle for a little bit because, as you know, and my audience, I'll let know, my daughter, Katie, is the next mayor of Seattle. And so this has made Seattle very interesting to me. And I want to know what's been your relationship with the city of Seattle? What's been the relationship between UW and the city of Seattle? Is it a good example, a bad example, in between? So talk to us about you being in Seattle at a very, very distinguished university. And so, if ever there could be a strong relationship between the city and the university, Seattle should be an excellent candidate. But is it? So let's turn to that.
yeah. Well, I'm fortunate to live here. With the type of questions that I have, um, and my interest in my work, Cascadia already, as a larger system, is a complex adaptive system. We live between tectonic plates, atmospheric rivers, rapid warming climate, so flooding, wildfire exposure, biodiversity loss,
You name it.
and yeah, and unaffordable housing, transportation challenges create a very tightly coupled set of risks and opportunities. And I think we're facing that. But Seattle, I see that because I do have been seeing since I've been here that Seattle and the Puget Sound have a really great opportunity to kind of represent a kind of a global model of a new way of rethinking planning and rethinking strategies for the future. And have, as a student, I would say, at the University of Washington, because I'm a professor, but I believe that I'm a student uh, primarily. I see the region as a natural laboratory, which has remarkable ecological assets, rapid economic growth and urbanization, a long tradition of policy innovation. In fact, also a community that is willing to experiment. Whether all those forces are really right now achieving the synergy that they could, I think is not yet where we are. And so, on one hand, we have those challenges. Urban land cover has almost doubled in the past 25, 30 years. The population growth will be in Puget Sound will reach about close to 6 million by 2050. So and urbanization has already transformed hydrology, has driven, major issues that you familiar with, you have heard of at least extreme flows, warmer summer. Um, so those are pressure on one hand, um, really signal that there is a potential um, ab- abrupt ecological change that may occur in a region that is so rich ecologically. On the other hand, also I see that sometimes that could occur simultaneously social transition, the same way in which ecological transition occur. And so there are opportunities that are driven by those forces that I mentioned before. For example, the scale of infrastructure retrofit, restoration investment, also housing initiative now, at least they are at least on the table, whether they are going to serve what they're supposed to, really can provide opportunity to change the region from the next century. Um, we have a world-class scientific community. We have strong regional and local agencies. And as I said, the public that is unusually uh, interested and receptive of experimentation, which is a critical
Yeah,
factor
and
in.
you have business corporations that could be enormous forces for good, and
Yeah.
in some cases have been. We have that too, and
But that requires vision. The key is to treat the region again as is an evolving socio-ecological evolutionary systems. So thinking about, I would say, this concept of multi-species design, adaptive water systems, community-driven resilience, cross just directional, just jurisdictional, sorry,
mhm.
um, planning, all of those things could be done. And the new city and regional government, I think, have the opportunity to take Seattle to this other new level. But the key will be not to tackle housing, climate, biodiversity, social equity as a separate silos problems, but actually as an interconnected challenge. And that's
Yeah,
when I brought up the experience I had in Singapore, where they have a very clear plan about working and as at the interface among those critical challenges, because they are interdependent and they not only can um, you know emphasize each other, but they actually can create opportunities that we don't see now.
Oh, great opportunities. I mean, just
Yeah.
so many positive externalities that can be fit together. So,
And
so
I think the barrier is not necessarily knowledge. Of course, we need to build more knowledge, but it's really coordination and building this the institutional uh, framework, the kind of the platform for creating a more greater effective collaboration among all those agents and seeing those opportunities of linking those problems as as a, plus right now the city has been working primarily in separate departments where of course they compete for different for limited resources,
yeah,
right?
lower level competition.
Yeah,
Yeah,
rather than exploring where the opportunities are at the interface among those and understanding how they connected to each other. You cannot do, you cannot achieve housing affordability if you don't deal with the climate change and vice versa.
yeah, yeah. So I think that this will be my final contribution to a wonderful conversation, by the way. So thank you so much. It's really appreciate this conversation. And you say we don't need new knowledge, more knowledge. I get what you mean by that. I mean, we got lots of knowledge, but I think
Yeah.
we do need a new perspective. And I think that unless you have this complex systems perspective, and I would also say an evolutionary perspective, which is informed by the knowledge that we already have and will always want more, that perspective is needed. So, for example, if you have, other mindset, including like neoclassical economic mindset or a technocratic mindset where you think that technology will solve everything when in fact it won't, and so on and so forth. So I do think that a certain holistic perspective is needed. And then that makes the science that already exists relevant. So we've got lots of complex system science, we've got lots of evolutionary science, but what we don't have is an appreciation of their relevance by as many people as we need to. So I think that's the kind of mental paradigm shift that needs to take place. And then when we do have this perspective, which you represent so well, then at that point, and when that's shared more widely and guides what we do, then we can solve some of these wicked problems um, better. But I do believe that the perspective is needed, and that's of course what people like you and me and many others have to offer. So here's hoping that in any city, by the way, or any locality. So Seattle is where you live, and what has suddenly gained a lot of interest for me. But this what goes for Seattle goes for any location on Earth. As we've mentioned, Singapore, halfway around the world, any city or any region can begin to uh, evolve its complex systems with this toolkit, as I often put it. And so that's what I think I'm hopeful about, and I sense that you are also.
So when I say it's not that um, we don't need, I want to clarify, we need a lot of knowledge.
Yeah,
But I agree with you, we need a new perspective. But what I meant by that is that when I said that we don't need new knowledge to start to make progress, was meant I meant we don't need to wait for new knowledge to make progress. But
yeah,
also it means something else that we don't need the type of knowledge that we have produced so far. That we need to produce new knowledge, and in order to do that, we need to build a partnership uh, between academics, scientists, and communities in a way that the problems that we are studying are codified by both the scientific community and society together. We need a knowledge, we need to, of course, we still need basic knowledge, but there is one part of knowledge that is not yet uh, emerging from the current separated silos of production of knowledge. There is the knowledge that has this co-defined, and so what we need, when I said a platform for research co-production, where scientists, planners, communities,
Yep.
agencies work together from the start, generating knowledge that is both actionable and that is
Yep.
scientifically rigorous.
Perfect. No, that's great. That's a perfect way to end. Well, thank you, Marina.
Thank
And I
you.
do hope that we have a chance to work together in Seattle or any place else. So this has been wonderful.
Thank you.